What is the slope of this line? It is what we have discussed before, which is your y2 minus y1, y2 being the return on the market, right? Over x2 minus x1. So x2 is your standard deviation of the market, x1 is 0. So that is your slope. And we know that. And the slope is not changing because we're assuming that the risk-free rate at which we were lending to the government is also available for us to borrow money from the government at, right? So we can even borrow money from the government at this rate. But the real question is, can we? I mean, if you are lending to them at 10%, but if you want to borrow from them, or if you want to borrow at the same rate as the government, I don't think that's practical, because the government is borrowing, which means they can pay back for sure. But if you are borrowing, the risk is higher with you than it is with the government, right? So you then might have to pay a higher rate. And if you pay a higher rate, then what happens to your slope? Well, your slope goes down. And therefore, you can see that the borrowing portfolio can have a lower slope than your lending portfolio, right? And if you put them together, this is what you see. Now, what does this mean for us in terms of passing the exam? So let's have a look at a couple of questions just to make sure that you are able to get your calculations right. So now this chap becomes a little greedy, right? And he decides to not just invest all of his own money, but decides to borrow some money and put that in the market as well. Definitely something I would never do, right? Because I have burnt my hands in the past. But anyways, let's focus on the exam. So, well, this guy is now borrowing money at 10%. So he looks like he's still paying what he was earning. So the risk-free rate was 10%, and now that he's borrowing, he's able to somehow magically borrow at that rate. So anyways, let's solve this question, because I know the next one we're going to increase this. So let's do this first, and then we'll increase it and then see how that impacts his risk and return. But for now, he is being able to borrow at the risk-free rate at which he was earlier lending at. And the market return is supposed to be 16%, standard deviation of 30. Your job, my friend, is now to calculate the risk and return that this guy would make, right? And remember, return will be a weighted average. And if he is investing 150% into the market portfolio, so you take that of the market, whereas if he is actually investing negative in the risk-free, so then you would give a weight of minus 0.5 to that, right? So that's how you can calculate the return. And the risk, similarly, you have to weight it, give it a weighted average approach as well, with 1.5 to the risky portfolio, the market portfolio, and minus 0.5 to the risk-free, which basically has a risk of 0. So try to solve it, and then I'll show you the solution. Right, so hopefully you were able to actually calculate the weighted average of the returns, with 1.5 weight being applied to this market, which is paying a 16% return, right? And minus 0.5 return being a weight being applied to the risk-free asset, because instead of earning this, we're going to be paying this, right? So the weighted average is 19. And as far as the risk is concerned, well, it doesn't matter what's the weight of the risk-free asset, because the standard deviation for that is 0. So this gets cancelled out. And the only thing we need to see is what is the weight of the risky portfolio and what is the standard deviation. So since we are putting more than 100% of our money, the standard deviation of the portfolio actually goes up, right? So I mean, if this is the market portfolio and this is your capital market line, and since you're going beyond the standard deviation of the market, you're actually borrowing money and putting it in. So your standard deviation is going to be more than the standard deviation of the market, right? Now all numbers are the same. The only difference now is that he has to pay 12% instead of 10. So now he's earning 16, but instead of paying 10, he now has to pay 12, and the same detail is there in terms of your standard deviation. So this becomes your slope now, right? And what was the equation? Y is equal to mx plus c, and your c is the risk-free rate, which now becomes 12, and x is basically the amount of standard deviation that you're taking in the portfolio, which again you have to calculate how much he's taking. So now your job is to calculate the return. You will only be able to calculate the return if you figure out how much risk he's taking, which is something you should be able to do because we just saw that. And also then calculate, that's what you have to do, calculate the return he would make and how much is the risk he's taking, which I believe should stay the same because even before he was putting 1.5 times, the money, and the standard deviation of the portfolio hasn't changed, of the market hasn't changed. So the risk shouldn't change, is the return that should change. So try and calculate this and then I'll show you the answer. Right, so hopefully you were able to figure it out that the risk stays the same because, think about it. He's putting still 150% money in the market portfolio, which has a standard deviation of 30. So the risk is not changing. But it's the slope that is changing. So y is equal to y-intercept, which is c, which is the risk-free rate, right? That's 12% now, before it was 10. And the slope then becomes 16 minus 12 over the standard deviation. So that is your y2 minus y1 over x2 minus x1. And then we are going to multiply the slope by the amount of risk we're taking. So because the slope basically tells us, okay, this is the rise over run. So you know the rise over run. So you know the slope of the line, but you're not really taking a standard deviation equal to the market. You're actually taking a standard deviation more than the market, right? So then that's the x we plug in. Right? And then this is the slope. So let's call it mx. And then this is the c, which is your y-intercept, and you get your expected return, which is 18%. You could also do it like this, where you just give a negative 0.5 weight to the risk-free and a 1.5 positive weight to the market portfolio. And you get your return, expected return, right? The only thing here is that before we were putting 10, now we've put 12. So much simpler way of doing it. But why I've showed you the whole changing of the slope and everything, because obviously I want you to really understand this concept in a very nice way. All right, I think let's take a break here and then we'll come back and jump into this very interesting concept of systematic and non-systematic risk.